Half of them didn't come home. Half of every F-105 ever built gone. Swallowed by the jungles of a country most Americans couldn't find on a map. Flying a mission the aircraft was never designed to fly. Dropping bombs it was never designed to carry. Fighting enemies it was never built to fight. And the men who survived, the ones who strapped themselves into that machine day after day, who knew the odds, who had done the math and climbed in any way they had a name for it, not the proud name Republic Aviation stamped on the fuselage, not the name the Pentagon put in the press releases. They called it the Thud, as in the sound of 24 tons of metal hitting the ground. That name was born from grief, from dark humor, from the particular kind of honesty that only comes when men are living too close to death to bother with anything else. And yet find one of those pilots today, look him in the eye, ask him about that airplane and watch what happens to his face. The grief is still there, so is something else entirely, something that looks almost like love. That contradiction is the whole story. A machine born for the end of the world, thrown into the wrong war, broken apart by it, and somehow, in the breaking, it changed everything. It begins not in the jungles of Vietnam, but in the coldest, most paranoid years the 20th century ever produced. The year is 1951. The Soviet Union has just tested its first hydrogen bomb. America is scared. And when America is scared, it builds things. The Air Force handed Republic Aviation a design brief that read like science fiction. Build us a plane that can do all of this at once, fly at treetop level, break the sound barrier without diving, penetrate Soviet radar defenses at high speed, release a single nuclear weapon from a sealed internal bay, and then outrun the shockwave of its own bomb. One pilot, one engine, one shot at preventing World War Roman III. What Republic Aviation built to meet that requirement was, by any reasonable measure, a monster, 64 feet long. Maximum takeoff weight of 54,000 pounds. At the time of its introduction, the F-105 Thunderchief was the largest, heaviest single-seat combat aircraft ever built by any nation on Earth. Its Pratt & Whitney J75 engine, in full afterburner, generated over 26,000 pounds of thrust and pushed the aircraft past Mach 2 in level flight. The internal bomb bay, engineered down to the millisecond, could open, release a nuclear weapon at supersonic speed, and seal shut again before the shockwave caught up. This was a machine built for one scenario, the apocalypse. Then history, as it always does, changed the plan. By 1964, the war wasn't in Europe, it was in Vietnam. And the Pentagon's premier nuclear strike aircraft was being pointed at jungle roads and river bridges with no nuclear weapons involved whatsoever. The internal bomb bay, that precision-engineered nuclear cradle, was welded shut and packed with extra fuel tanks, because Thailand to North Vietnam and back was beyond the aircraft's original range, with the bay sealed. Every weapon had to hang on external pylons under the wings, under the belly, turning what was supposed to be a sleek, supersonic interceptor into something the pilots named with dark accuracy, a bomb truck. And the numbers behind that nickname were staggering. A fully loaded F-105 on a rolling Thunder mission could carry up to 14,000 pounds of conventional ordnance on those external pylons. That is more than the typical bomb load of a B-17 Flying Fortress, the four-engine heavy bomber that firebombed Nazi Germany. Carried by one man, on one engine, at the end of a 600-mile flight through what would soon become the most dangerous airspace on the planet. At least one F-105 was painted with the nose Art Memphis Bell Roman II, the name of the most famous B-17 of World War Roman II. The pilots meant it as a joke, a dark one, the kind of joke you make when the alternative is not laughing at all. April 4, 1965. 48 F-105 Thunderchiefs roared north from their bases in Thailand that morning. Fully loaded, tight formation, headed for a bridge over the Ma River that American pilots had nicknamed the Dragon's Jaw. The Vietnamese name, Ham R-1ED3NG, meant the same thing. It turned out to be prophetic. The bridge was the critical choke point on North Vietnam's supply lines heading south. Destroy it, and you cut a vital artery. The Pentagon had made it priority one. The pilots were focused, professional. They'd trained for this exact profile, the run-in. The bomb release, the pull-off, everything was going to plan. Then the sky split open. 4 MiG-17s punched through the low cloud deck without warning directly into the formation. Korean War technology. Subsonic. By 1965 standards, these aircraft were essentially ancient, and in the next 60 seconds, they shot down 2 F-105s. Major Frank Bennett, Captain James Magnuson, gone when the news reached Washington. The Air Force Chief of Staff reportedly leapt from his chair in fury. How could the most advanced single-seat fighter on the planet be killed by a subsonic relic from the 1950s? The answer was physics. Brutal, unforgiving physics. The F-105's swept wings were designed for one thing: raw speed in a straight line. They were small relative to the massive fuselage, which created wing loading of 93 pounds per square foot. That number means something very specific in a turning fight. The moment a Thud pilot tried to follow a MiG into a hard turn, he began bleeding energy catastrophically. Every degree of bank cost airspeed. Every loss not made the aircraft heavier, slower, less responsive. One veteran pilot described it without a trace of self-pity: his airplane, he said, needed half the state of Texas just to make a turn. He wasn't exaggerating. He was doing the math out loud. The MiG-17 was light, agile, with enormous control authority at low speeds. It was built almost perfectly to exploit exactly that weakness. In a turning fight, it didn't just beat the F-105, it owned it. So F-105 pilots developed a different instinct. The moment a MiG appeared, the hand went straight to the jettison button. Bombs gone, tanks gone, pylons gone, everything dropped away in a single explosive flash. And in that moment, stripped clean. Something else woke up inside that airframe. Full afterburner. 24,500 pounds of raw thrust at low altitude. In a straight line, a clean Thud could hit Mach 1.2, nearly 900 miles per hour, at treetop level. The MiG-17's top speed was Mach 0.93. Subsonic, always. The chase was over before it began. MiG drivers watched the Thud simply vanish into the distance. Trailing blue fire, and there was nothing they could do about it. That was how F-105 pilots survived the MiG problem. Not by outfighting it, by outrunning it, but MiGs were only half the threat, because waiting above North Vietnam invisible, patient and far more systematic than any fighter pilot, was something that couldn't be outrun. Something that didn't need to see you to kill you. Picture this. You're at altitude, instruments green, formation tight. And then your radar warning receiver, a small panel on the dashboard that most pilots prayed they'd never actually need, goes from a slow pulse to a solid, continuous scream. You've been locked somewhere beneath the cloud layer. A North Vietnamese crew has just illuminated your aircraft with the Fan Song radar of an SA-2 missile battery. They have your altitude, your heading, your speed. In approximately 8 seconds, a missile the size of a telephone pole, traveling at 3 times the speed of sound, is going to arrive at the exact piece of sky you're currently occupying. Your options are simple, and both of them are bad. Fly high, the SAM kills you. Dive low to evade the SAM, and you fly directly into the curtain of anti-aircraft artillery that the North Vietnamese positioned specifically to catch pilots who dive. There was no safe altitude. There was no safe corridor. This was a trap built by Soviet engineers and operated by North Vietnamese crews. And it was working exactly as designed. Something had to change. And the solution the Air Force came up with was, depending on how you look at it, either a stroke of tactical genius or an act of institutionalized insanity. Probably both. They would create a unit of pilots whose sole purpose was to fly directly at the SAM batteries. Voluntarily, use their own aircraft as bait, force the radar operators to activate their systems, and then kill the radar before the radar killed them. They called the mission Wild Weasel. And when the first crew was briefed on what it actually involved, the electronic warfare officer's response became the unit's unofficial motto, 4 letters that were stitched onto patches, painted on aircraft and said out loud before every single mission. Igbsum, you gotta be SHing me. The formal motto was 4 words, but they landed harder than any battle cry. First in, last out, to make the F-105 into a Wild Weasel. Republic Aviation literally cut it open, stretching the nose 31 inches to accommodate a second cockpit. That rear seat belonged to the electronic warfare officer, a man the pilots called the Bear. The name was earned, because to willingly sit behind someone whose job was to fly toward missiles, you had to be either extraordinarily brave or completely beyond caring about the odds, often both. The aircraft hunted using the AGM-45 Stryker missile that followed enemy radar beams back to their source like a bullet riding a thread of light. The problem was range. The Shrike reached only about 15 miles, which meant to fire it. The crew had to fly to within 15 miles of a system specifically designed to kill aircraft at 30. They had to get close. Deliberately, knowingly, calculatedly close. Every mission. Captain Jerry Hoblet was 31 years old. Before Vietnam, he'd been a math teacher. He had a wife and 2 kids at home. On April 23, 1967, he was leading a strike package toward Thai Nguyen, one of the most heavily defended target complexes in North Vietnam. Roughly 50 miles north of Hanoi, his bear was Captain Tom Wilson. They were still ingressing when the roar lit up. Fan Song radar, active, tracking. Wilson's voice came through the intercom, flat and completely controlled launch. Launch 3 SAMs, 10 o'clock, 3 SAR-2s, in the air, climbing fast. What Hoblet did next was not instinct. It was training refined into something beyond instinct, a series of violent, precisely timed breaks designed to force each missile to overshoot. Not too early, or the missile corrects. Not too late, because at that point physics doesn't leave you any room. 3 missiles, 3 breaks. 3 misses by margins that were later measured in feet. And then, instead of turning for home, Hoblet turned toward the battery that had just tried to kill him. They fired Shrikes, rolled in and bombed. When a reconnaissance aircraft in their package took a hit and went down, Hoblet didn't leave. He stayed in the target area, drawing enemy fire toward himself, giving the downed pilot a better chance of survival. For that mission, Hoblet received the Air Force Cross, the second highest decoration for valor in the United States military. Wilson received the Silver Star. 2 other Wild Weasel crews from that era received the Medal of Honor, both posthumously. The first Wild Weasel deployment lost approximately 50% of its initial crews killed, wounded, or captured within the first weeks of operations, and yet the program worked. Not by making the skies safe, nothing could do that, but by changing the calculus on the ground. Before Wild Weasel, North Vietnamese batteries were firing an average of 15 SAMs per American aircraft destroyed. By 1968, that number had climbed past 48, 3 times the expenditure. Same result, because the radar operators were terrified. They knew that the moment they turned on their equipment, something was already turning toward them. That fear purchased with the lives of Wild Weasel crews is the foundation of every suppression of enemy air defenses mission flown anywhere in the world today. But even with Wild Weasel running interference, the Thud still had to survive something more intimate. Something that happened close enough to see the other pilot's cockpit. And it's in that close range fight that the F-105 delivered the lesson that changed American air power permanently. Major Fred Tracy's flight was aggressing from a strike on June 29, 1966, when MiG-17s hit them from below. No warning. 1 second clear sky next second, a 23 cannon shell detonated beneath his aircraft. The concussion ripped his hand off the throttle, killing afterburner instantly. The round destroyed his oxygen system, shattered instrument panels, and obliterated his gun sight completely. His F-105 was losing speed, losing systems. Going dark. To understand what happened next, you need to understand the Thud's most dangerous design flaw, the one baked in from the very beginning. Republic Aviation had designed 3 independent hydraulic systems for redundancy, sound engineering on paper. But they routed all 3 lines in parallel, running side by side through the same narrow channel in the lower fuselage. At 50,000 feet on a nuclear strike profile, this was irrelevant. At 500 feet over North Vietnam, with every gun in the country pointed upward, it was a death sentence. A single rifle round, not a cannon shell. A rifle round in the right spot on the belly would sever all 3 lines simultaneously. Hydraulic pressure gone. Horizontal stabilizer drives to full deflection. The aircraft pitches nose down, unrecoverably, in under 2 seconds. No ejection, no recovery. Pilots called it going ballistic. They didn't mean it as a metaphor. Tracy's hit had landed close to that channel. Very close, but not close enough. The Thud kept flying, barely, and then physics offered Tracy the only gift it had. The MiG that shot him was moving too fast. It overshot, pulled up hard, and suddenly filled Tracy's shattered windscreen. No gun sight, no systems, the aircraft barely controllable, but there, in the left side of the nose, always there. Always loaded was the M61A1 Vulcan cannon. 6 rotating barrels, 1,028 rounds of 20 ammunition, 6,000 rounds per minute. Tracy aligned the aircraft using his eyes and the pitot tube on his nose as a rough reference, and he fired. 200 rounds in under 2 seconds. The burst walked across the MiG's left wing route. The wing separated. The MiG fell. First confirmed aerial kill for the F-105. One with a broken aircraft, a shattered gun sight, and a pilot who'd been flying long enough to not need either. Now here's the part of this story that matters beyond one man's survival. While Tracy was fighting in a damaged Thud, the F-4 Phantom, Roman II, America's other primary fighter in theater, faster and more capable by nearly every metric, was struggling in ways the Pentagon hadn't anticipated. Because the men who designed the F-4 had made a decision that seemed perfectly logical in a war room and proved catastrophic in the sky. They removed the gun. Early F-4 models carried no internal cannon. None. The reasoning was clean. The future of air combat was radar and long-range missiles. Close-range guns were a relic. Why carry dead weight? The AIM-7 Sparrow would handle everything at distances where the enemy never even saw you coming. Then reality arrived. The Sparrow's combat failure rate in early Vietnam conditions approached 90%. Rules of engagement required visual identification before firing, which forced pilots to close to distances where the radar missile was already inside its minimum engagement range. F-4 crews found themselves in knife fights with MiG-17s at point-blank range with no knife. The exchange ratio that resulted was so poor the detailed numbers were classified. Meanwhile, the cumbersome bomb truck was quietly killing MiGs with its cannon. Of the 27 and a half aerial victories credited to F-105 crews in Vietnam. 24 and a half were gun kills. Nearly 90%, with a weapon that doctrine had declared obsolete. The lesson was impossible to argue with. Within 2 years, the F-4E was rushed into production with a gun. The Navy established Top Gun specifically to rebuild the close-range dogfighting skills that official doctrine had abandoned. And from that point forward, no American combat aircraft has ever gone to war without one. The F-22 has a gun. The F-35 has a gun. They always will, because the men in those broken Thuds proved, at the cost of their own lives, that no amount of missile technology replaces the ability to put rounds on a target at close range. 382 F-105 Thunderchiefs were destroyed in combat over Southeast Asia, nearly half of every aircraft ever built. At the worst periods of rolling thunder, a pilot assigned to the Thud had roughly a 40% chance of completing a full combat tour alive. He knew that number. He climbed in anyway. Those men and what happened to them were not wasted. In the data generated by the F-105's combat record, Colonel John Boyd and mathematician Thomas Christie found the raw material for a theory that would rebuild American air power from the ground up. Boyd had watched the Thud hemorrhage energy in turning fights and understood instinctively why it kept losing. But he wanted equations, not intuition. What he built working from F-105 performance data as a baseline was energy maneuverability theory, a framework proving that a fighter's true combat value wasn't raw speed or raw thrust, but its ability to manage total energy through every phase of a fight, gain it, spend it, recover it. Faster than the opponent. Applied to the F-105, the verdict was surgical. The J-75 engine was magnificent, but the aircraft's mass and wing loading caused it to bleed energy in any maneuvering engagement faster than the engine could restore it. Power without agility wasn't an advantage. It was a trap that cost hundreds of men their lives. Applied to the drawing board, Boyd's theory became the genetic code of what came next. The F-15 Eagle, designed with an unprecedented thrust-to-weight ratio and low wing loading, was the first aircraft built using energy maneuverability theory from the ground up. It has never lost an air-to-air engagement in combat, not once in over 40 years. The F-16 Fighting Falcon lighter, more agile, designed explicitly for the close-range fight, became the most produced Western fighter of the post-Vietnam era. Both aircraft trace their lineage, in a direct and unbroken line, to what the F-105 broke and to the men who were inside it when it broke. And the Wild Weasels, every seed mission flown anywhere in the world today, every HARM missile fired, every electronic warfare aircraft blinding enemy radar before a strike package crosses into contested airspace, carries the DNA of what those crews invented over North Vietnam. The F-35 carries jamming systems that would have seemed like science fiction to the bears of the Wild Weasel squadrons. But the mission those systems execute is exactly the mission Jerry Hoblit flew in 1967. First in, last out. The F-105 Thunderchief was called the Thud as a joke. The sound of all that ambition and metal hitting the earth before it had the chance to come home. But something shifted over North Vietnam in the smoke above the Dragon's Jaw. Above the SAM batteries and the radar nets and the rivers and the mountains, the name didn't change. The meaning did. Thud became the sound of 14,000 pounds of ordnance arriving on target. The sound of a Shrike riding a radar beam home. The sound of a Vulcan cannon ending a MiG's last second of flight. The men who flew it buried friends in it. Crawled home in aircraft held together by hydraulic fluid and structural stubbornness. Went back the next morning and flew again. 382 aircraft, hundreds of men. Lessons paid for in the only currency that war has ever accepted. The Thud is gone. But everything it cost and everything it taught is still up there, still flying.